Yes. Firstly, I would like to introduce myself. I am Dr. İsmail Büyüksalih. I work for 3D Mapping and GIS department in BİMTAŞ. I got BİMTAŞ company. I got a placed a lot of projects such as airborne lidar, terrestrial laser, mobile mapping, remote sensing, photogrammetry, etc. Today our presentation including motivation, introduction, solar energy, 3D game engine, Unity, solar energy efficiency software for Istanbul City, result and discussion, lastly conclusion parts. You cannot manage the things if you don't measure. You cannot improve the things if you don't manage. How to measure? Accurate data, robots, method, software. We have to combine them. I want to mention accuracy items. If we got a data from 500 meters, we get more than 5 centimeter accuracy. If I acquired that data from 1 kilometer from ground surface, we can get a more than 10 centimeter accuracy in vertical and horizontals, according to ASPRS 2009. Motivation. Solar energy modeling is increasingly popular, important and economic significant in solving energy crisis for big cities like Istanbul. It is a clean and renewable research of energy that can be utilized to accommodate individual or group of buildings electrical power as well as for indoor heating. Introduction. Actually, 3D technologies we provide the 3D technology from 3D technology. 3D technologies offer us the facilities in the last years in many applications. For example, a computer-aided analysis technique using lidar and plan view data for identifying high potential areas for solar power implementation. For example, there is a project in Berlin, a case study to determine how solar power can be optimized on urban roof areas using photovoltaic and thermal solar panels. Similarly, BİMTAŞ carried out a project to model potential of solar estimation for cities' energy planning. Solar energy efficiency performance of the buildings in Istanbul. As you know, sunlight comes to Earth as a form of electromagnetic radiation. Solar energy is a radiant light, and heat from the sun is very beneficial and crucial as renewable energy. There are two categories, passive and active solar energies. Passive solar energies including selecting materials, space designs of building for circulation of the air, while active solar energy, photovoltaic systems, and solar water heating. As you see in the figure, in the solar panel of the building, example of active solar. This system consists of the solar panel, solar inverter, cabling, and electrical accessories, maybe etc. In this station, it's converted light directly into electricity. 10 kilowatts, from 10 kilowatts to hundreds of megawatts. We came to our project implementation. We have a data sets as a 3D last data, DSM, DEM, NDSM, through orthophoto and 3D city model in LOD2. At the same time, buildings model can be extracted from orthophoto and LiDAR data. We got a DSM and DM product from the LiDAR data, and we reached the LiDAR project in 2 years, approximately 3 years, 2 years ago. The 3D city buildings for whole Istanbul has been generating by using LOD 2 and 3. 3D city modeling. 3D models are most suitable option for detecting the shadows and other parameters in the estimating the potential solar energy. At the same time, buildings are the largest consumers of energy and collecting the solar energy. But in this, I will mention about the limitation in the next slide, but I give some of limitations such as shadows, clouds, direct and or indirect of sunlight, and intensity and the direction of panels. These are very important for us. STGML and LOD. As you see in the figure, effects of LOD 1 and LOD 2 in shadow calculation. If we use the black drawing, only solid model, actually we can measure the difference of LOD 2 and LOD 1. What is the difference of LOD 2 and LOD 1? This red line, difference red line and green line. It is much recommended to use LOD 2 instead of the LOD 1 and LOD 3. Compare the LOD 4, better accuracy for solar energy prediction. Estimating the solar energy. Wayland et al. In 2050 proposed a combined method to compute solar radiation received per month by roof surface and building walls on the STGML 3D city model. We looked at the basic workflow for the combined method. Firstly, establishing a point grid on roof and facade surveys of buildings, then determination of shadowing and computation of solar irradiance for each surface point, and lastly, integration with the respective time interval. What does mean time interval? Sunlight movements and heat for the year. As you know, June 21st and December 21st is very important date for us because sun is the sun at the sky with its lowest arc in the December 21st, while June 21st sun travels with a high path through in the sky. Unity 3D game engine. Unity is a cross-platform game engine normally used to develop 2D or 3D video games and simulations for computers, virtual reality, consoles, and mobile device platform. It's a commercial software developed by Unity technology and free. I want to mention in details our project implementation. LiDAR point cloud gathering from airborne LiDAR technology. Then we classified automatically in the by using the TerraSolid model. We got a ground and building class. Then in the Terra model, we made a vectorization of buildings, then converting the buildings DGM to XML files by using the FME software. Then import the XML files to buildings, DTM and orthophoto in the city grid. Convert the corrected XML to shapefile and STGML in the FME. Lastly, transforming building, orthophoto, DM, XML, and all data transfer the FBX format in the Unity. build-up function. In Unity, we can easily see in the viewer standard mapping function such as zoom in, pan, information, and on-off layer were built based on Unity game engine. In Unity, Unity has a specific function such as query, shadow calculation, solar radiation, sun locator, and angel were embedded in the equation and internal codes. We cannot see in the viewer. What is our inputs? I mentioned some of inputs data. For example, building data, HTML, air pollution data, ground data. Then we are outputs, visualization of air pollution, analysis of the solar heat for multiple buildings. In the middle section, you can see the solar energy software. This is our software. We named the projects as a İstanbul Güneş Enerjili Verimliliği. You can easily upright view. This is default view. In the lower right figure, show us selection of particular building before calculation, the potential solar energy. These figures give us the rooftop as a solar panel before and after the calculation. We can select the roofs and we can determine the roofs area and product epic